Yes. Is it? Yeah, 8 over 15. Good. If you see 8 over 15, you're doing it. You've got it. All right. So, Keith is just yelling out 15. 15 would be the least common multiple between 3 and 5. A least common multiple is a high number that both numbers can divide into. So we've been factoring for a long time. Factors are lower numbers, multiples are higher numbers. So when I'm trying to pick a common denominator, I'm actually going big. Go for a bigger number. 3 times 5 is 15. That's one way to look at it. The common denominator would be 15 here. And that is called a least common multiple. That's a multiple of 3 and 5 that they have in common. So in order to turn 3 into 15, you would multiply the first fraction top and bottom by 5. And in order to turn 5 into 15, you'd have to multiply that second fraction top and bottom by 3. So 1/3 is the same as 5/15, and 1/5 is the same as 3/15. Now we can add them, and the sum would be 8 over 15. All right, number 2. The least common multiple is 12. If you pick 24, that's okay. You can do the problem with 24. At the end, you'll have to reduce. 24 is a common multiple. It's just not the least common multiple. So I put a 12 in. I think to myself, well, how would I turn this fraction into a denominator? With 12, I'd have to multiply the top and bottom by 2. Add across the top, 7 over 12. Good? Number 1 and 2, good. It's all coming back to you, right? Those fractions. If you stick with this, you'll understand fractions better than you have ever. Okay, number 3. What would be the LCM in number 3? 6 and x. You just have to include everything. So as soon as they start throwing in variables, just make sure you include that in your common denominator. So I'll write out 2 fractions with the new common denominator and multiply in whatever's necessary. The first fraction already had 6 and x, so it can stay 5. The second fraction did not have x, so I'll multiply x into the top and bottom. Now that you have a common denominator, you can add across the top, getting 5 plus 7x all over 6x. Number 3 should be good to go. All right. So to be honest with you, I think that everybody in here, first off, I know you already know how to add fractions. Second off, throw the x in there, not all that different. Now this is where you're going to see information that looks a little less recognizable. Erase all these highlights. I just love highlighting. Okay. So for denominators with variables, the LCM must contain 2 criteria. It has to contain every variable's highest exponent. So when you're trying to decide what will the common denominator be, pick the highest exponent. And it also has to include every factor in every denominator. So we're just going to list everything in our common denominators. So your first task is to just kind of pretend. It's going to give you 2 terms. And you're kind of pretending if these were denominators, what would the common denominator be? So it doesn't show you, the assignment won't show it to you as a fraction. It'll show you like this, but you can kind of visualize, okay, if I had to add these 2 fractions together, what would the common denominator be? So when I look at number 1, I'm thinking, what number does 5 and 6 both go into? 30. So I'm thinking of a high number. 5 goes into 30, 6 goes into 30. Maybe that's one option. Sometimes it'll come out too big if you just multiply them. All right, so 5 and 6 can both go into 30. And then I have to look at the x's. We have x to the third and x squared, so I pick the highest exponent, x to the third. And then I look at the y's. I have y to the first and y to the fourth. I'll pick the highest exponent, y to the fourth. So the least common multiple between those two expressions is 30, x to the third, y to the fourth. It's a high number and high exponent. All right, number 2. As soon as you're given an expression that can be factored, it must be factored to figure out the LCM. So how do I factor this one? That looks like it factors by GCF. I can pull a 3 and an x out. 3x. So I'm going to pull out 3x, and that's going to be x plus 1. So I'm going to ignore the original by, and I'm going to focus on the factored version of that when I'm picking the common denominator, the LCM. All right, so I'm going to look at 9 and 3. What's the LCM between 9 and 3? 27. 9. So you hear what you did? You multiplied them together. You can do the problem with the 27 here. At the end, all of your numbers are going to be triple what they should be. You'll have to divide everything by 3 in the end. So the advantage is just realizing 3 goes into 9 and picking 9. It's all your numbers will be smaller. All right, so the 9 and the 3 are taken care of. Now I'll need between x squared and x, I pick the highest exponent, so I'll do 9x squared. So those are taken care of. And then I have to put every factor in the LCM, so I'll have x plus 1. 9x squared, x plus 1.
So is number 7 on the paper?
No, you need to do these problems first. You're cheating yourself of real practice by doing that. I'm gonna help you with this. Can you figure it out with this one?
So one factor, right?
Yep.
So we're going to do x plus x minus 1 and x plus x plus 2.
What multiplies to 3 and adds to negative 4 will be x minus 3, x minus 1. So I take away the standard form and I only use the factored form. What about that first one? That first one factors by GCF. Take a 2 out, x minus 1. So what's the LCM?
2x. 2 times x minus 3.
I gotta put 2 in there for sure. I gotta put x minus 1 in. And when I put the x minus 1 in, I check it off of both here and here. And then I gotta put the x minus 3 in. Check. There's the LCM. All right, Josh, you're up. Number 4 here.
Okay.
Factor both of these. Let's take a GCF out first. Okay, what are they? -2. All right, so I'm boom ignoring that using the factored form. All right, factor the first one. For sure. That's a difference of 2 squares, x plus 2, x minus 2. All right, so the challenge is still factoring. Okay, so you got to factor that first one completely. You got to factor the second one completely. Now, Josh, what would be the common denominator? What's the least common multiple of these two things here? 24 is a multiple, but it's not the least common multiple. 12. Okay, so the 4 and the 6 I'm checking off. They both go into 12. What's next? X plus 2, check. X minus 2, check, check. X minus 2 again. You can. You got that? You did. X minus 2 squared that time. I wonder why it's not for the third. The third. All right, people. That is kind of most basic to most difficult there at the end. Quite a bit contingent on your ability to factor, but number 1 is not factoring at all. So if you can't factor, you can definitely at least do number 1. Your assignment is 7 through 21 odd. So get to that. I'll make it available online, and then I'll start taking questions on that for the rest of the class.